and you can take the floor.
Sorry about that. I got a bunch of windows here that are open. All right, so let's see if I can share. And I share you. So everyone should have a screen. How's that look? Oh,
Looks
perfect.
beautiful.
All right.
It's somehow
Uh,
quieter than I would expect in there.
yeah, I'm not in the machine room, hopefully. Thankfully, not today. All right, so let's take a look at perfect. So I was trying to think about how to talk about security and touch upon networking in such a short period of time, and I didn't have a really good answer for that, and it's kind of hard to cram everything into one session. So I'm prefacing this talk with you are welcome to ask me aside for details or for how-to type activities, or if you want to have a more hands-on session, we can do something like that. But I don't want to try and cram it all into a single session because I that's just going to be painful. So let's throw everything away and start with well, let's start from the top with a philosophical journey into security. And it's not a destination, it's more like a journey. You don't get to a point where you go, I'm secure, I'm done, I'm going home now, everything's good. It's more like you got to keep chipping at it and be aware. And we're gonna go from here. Knowledge is power. Power and knowledge are very closely related, and that is also the case here. So fortunately for us, all the attackers, they have the knowledge. They know what they're looking for. They know how they're going to get it. They know the extent of their resources. And guess what? We still have to keep them at bay. So right now, it's what we call an asymmetric threat. It means that the the amount of effort that you have to put into defending is grossly disproportionate to the amount of effort that an attacker needs to expend in order to get into your resources. Let me take you on a brief tangent that may help explain this a little bit better. Now, we mentioned that knowledge is power, and we don't know exactly what our attackers are up to. So consider, you go to the mall. Go to the mall around Christmas time, our holiday shopping is coming up, and that means that there may be thieves looking around in the mall to break into your car and steal your stuff. So conventional wisdom is, when you park at the mall, don't leave your bags in plain sight. Leave the shopping, put it in the trunk, put it somewhere where they're not going to see it. Or if you have nothing to cover, if you have nothing like that, at least throw a blanket or a towel or something over it so it doesn't look like, hey, here's all my shopping bag to go steal me. But we don't know what if our attackers aren't looking for that? What if they're interested in something else? That thing. For those of you who don't know, that's a catalytic converter. And up until recently, when California passed a law prohibiting the purchasing of catalytic converters from recyclers, these were really popular to steal and sell. And if your cat got stolen, you're out a couple $1,000. All right, so yeah, that's a little bit of a depressing way to start, where it's like, okay, what can we do? This seems like a losing battle as soon as you plug a machine into the network, but we have a little bit more control than it seems. A successful dice attack or just bad luck. It doesn't mean necessarily that the game is over, but what really impacts us are the consequences. But not so much there's someone in our machine, but what are they doing that's causing trouble for us? And we're creative people. We can ask the question, what if? And if there is mistakes, sorry, we can ask the power of what if and look upon the mistakes of others to learn their lessons so that maybe we don't make the same mistakes or see how they got burned and think about whether or not it's going to affect us and what we can do to get ahead of that. As an aside, there is a somewhat pervasive thought that prevention is security. As long as if you you have to prevent everything from happening, prevent all the badness from happening, and that is how you approach security. And it's not quite that way. Prevention is more like it's a subset of security. So another story. If you've grown up in Southern California, you may recognize this place. That is Magic Mountain up in Valencia, by LA. And I went there for the first time back when I was a kid. I was so excited, and it sucked. Do you know why it sucked? Because that. I was in such a rush to get out the door that I grabbed two shoes that were the same side, left side and left side. And I was feeling lazy, and I didn't bother putting them on until we got to Magic Mountain, which was about an hour away from where I was living at the time. And we got there, get the parking lot. They're like, Scott, put your shoes on. I'm like, all right, I'll put my shoes on. I put my shoes on and went, oh crap, it's all left sides. And I tell you, walking around that place with left shoes, it hurts. So applying that to security, lessons learned. Well, we can take the prevention route. Check your shoes before you're leaving. You might want to put your shoes on before leaving. I thought about that. And as I got older and became a student and found out that my funds were limited, sometimes the solution is you only have one pair of shoes. But there's also another option. That's like thinking ahead. What can go wrong? If that goes wrong, what can I do? That's planning for failure. It's not planning to fail. That's planning for failure. And in my case, my new fix is I'll just keep a pair of slippers in the car. And if that happens again, I'll pop them out of the car and go, here you go. Don't forget your shoes next time. All right, so let's talk about the rest of the talk here. Manage some expectations. As I said, we have a limited amount of time, but there's a lot of material that can be gone over. And so it's kind of hard to just say, here's everything you need to know about security in an hour. So I'm going to focus on things that are a little bit more related to the operation of a cluster, or in particular, the student cluster, where it's a thing that comes up and almost as quickly as it comes up, it goes away. So what do we do to protect and handle possible failure scenarios that may occur with your cluster? And let's go through some of those. We'll talk about some passwords, SSH keys, configuration as code. I'll get to that one, and I'll get to that one when I get to it. I'll have a question, but think about how you manage or are going to manage your cluster, and a little bit more about looking for trouble. So doing some inventory of network services, talk about the F word. And if there's time, and if my my live demo doesn't completely implode on itself, we can do some stuff with networking. I've set up a couple of VMs. I've broken them in a few different ways, and we can go through a troubleshooting exercise to see what's wrong with them. We talk about briefly the OSI model, and then something or another involving learning by mistakes and troubleshooting a broken machine. All right, so talk briefly about passwords. Just don't. That's the short of it, is don't. If you can avoid it, by all means, try to avoid it. But there are places where you can't avoid using passwords. When you're in that position, for example, you may have a service that only accepts password, like your lights out management or BMC or IPMI, whatever you want to call it. They're all roughly the same thing. Length is more important than complexity. You may have heard things about like complexity rules where you have to have a password that has an uppercase letter and a lowercase letter and a symbol and a number and an emoji, but it can't have a comma or a semicolon, all that kind of thing. Don't worry about that. Length is more important than any of that. Like I said, if you can avoid it, just avoid it. So more on passwords. Do you have default passwords? Think about, like I mentioned, your BMC or IPMI interface. You may not intend to use it, but if you're running a server, it's probably present on the board. And some of the servers, they will piggyback on the primary network interface. So you spin up your network interface, you plug it in, and you get it on the internet, and then your BMC will go, oh hey, look, I have an IP address. I'm gonna grab another IP address and and start serving up over there. And if you haven't changed your default password, you're going to be having a bad time. And if it's on campus here, or if it's here at SDSC, I'm going to be having a bad time, as some of you from last year might remember. I mentioned network gear. So if you got like a managed switch or managed switches, make sure to figure out what the default passwords there are and change them. And also if you have any applications, I don't know exactly which applications you're running, but if any of them have a service like, okay, run this and then log into the web interface and log in with admin and a password, that's got a default password, you might want to change that. Once again, change it. And over here, like I said, length is more important than complexity. That's a pretty reasonable password, but please don't use that password because it's sitting here in a slide deck somewhere. Okay, I'm going to move on to SSH keys, but before I do that, are there any questions? Okay, no questions. Let me talk a little bit about SSH keys. You may have heard of these, you may have used them before, but for those of you who have not, they leverage a technology called asymmetric encryption. So you have a key, an encryption key, and a counterpart. One undoes the other. So you have a key, another key, you have an encryption algorithm. Take an input, apply the encryption algorithm and the first key, you get some junk. You take the junk, you throw it into the decryption algorithm, you apply the other key, and it undoes the encryption, and surprise, you got your plain text back out. That is the fundamental of asymmetric encryption at a very high level. It's a gross oversimplification, but for our purposes, it should hopefully it's adequate. So how do you apply this to the authentication process? Well, we take one of those keys, let's call it the private key, and the public key. Public key goes on the server, so the server has a copy of it, and it's not a big deal if it's exposed because, as the name implies, it is public. The private key, however, lives on the client, or preferably on a machine like your laptop. We'll get to that in a second. The server wants to authenticate the client, so what it'll do is generate a random number, throw that over to the client and say, hey, do you mind signing this? Which is basically do something and encrypt it with the private key. So it'll run that encryption algorithm, encrypt the random number, throw it back to the server. The server has a public key that will undo the encryption, and hopefully the two numbers match. In this case, they do. So now the server is fairly confident that the client is in possession of the private key and is now authenticated. So you might be wondering, that private key thing, because it lets the client into the server or authenticates the client to the server, isn't that like a password? And isn't it unsafe to put passwords, store them electronically unless you encrypt them? Yeah, you're right. It is. It is a thing called a password equivalent. So, you're working with SSH keys, please put a passphrase on those. If you don't have a passphrase, bad things happen. Very bad things. Because eventually your key is going to get stolen, and it'll be used everywhere that you may have used it. And they will try to steal all the other keys that you may have had there. And it turns into a giant mess. And by giant, I mean hundreds of person hours spent responding to that type of incident. So please, password protect your private keys, or passphrase protect your private keys. So what does that mean? Protect your private keys. Well, first, keep them close. Keep them close to you. You want to keep the keys on a machine that you're touching, preferably like your laptop, your desktop, whatever you're touching, the keyboard that you're touching. You don't put them on your cluster. You don't put them on the login node. You guys still have ING9?
Yeah, I think so.
Okay. Yeah. You don't put it on ING9. You don't do any of that. You keep it on the machine that you're working with, that you're touching. And then it needs to have a passphrase. And by passphrase, I mean long long as like 24 characters long. You're like, whoa, hold up. Why is that so long? Well, if an attacker gets a copy of your private key, because it's a file that sits on your disk, they can throw it at a GPU farm and say, go brute force this. GPU farm, botnet, whatever, and guess millions of times a second. If your password is only 8 characters, sorry, if your passphrase is only 8 characters long, they're gonna get it, and then we're back to square one. If your passphrase is like 24 characters long, they'll probably give up and say this is costing too much money. It's not worth the effort. And if you're wondering, unlike passwords, it is okay to use the same key pair everywhere. So you want to use this, you want to roll a key pair and then put the public key on TSCC and here on your cluster and on some of your machines that you're using for classwork. That's fine as long as it's the public part. The private part needs to stay on your laptop. So now you're going, Scott, wait, what are you doing here? This is less helpful because I have to type that stupid 24 character passphrase in every time I want to log in, and it's just a trouble. It's so much trouble, and someone's actually told this to me. It must be really secure because it's a pain to use. But that's not the case. That there's a thing for that. It's called SSH agent, and that is a companion piece of software. It runs on the machine that you're touching, and you can load your SSH key into it. It'll ask you for your password or your passphrase once, and for the duration that the agent is running or until it's configured to expunge the key, it'll hang on to it. Protect it from being copied off and misused. And then all of your programs that invoke SSH, such as SSH, rsync, SCP, SFTP, they will all know to call to that agent and say, help me out here. And the other important part is, and this is where it becomes really useful, you can forward the agent, called forwarding or proxying, to another machine. So you can forward your agent to your cluster, you log in. Then from your cluster, it's exactly as if you had a copy of the private key sitting on disk unencrypted, except without the same security concerns. So you're on your cluster and you forwarded your agent and your agent has your key loaded, then you can just SSH off into wherever and you won't be prompted for a passphrase if the public key has been properly distributed. And so let's jumped back to configuration as code, and I asked a little bit of a question. How do you plan to manage the configuration of your cluster? There are tools out there that we use for our clusters. The one that we use is called Ansible. There are a few others that you may have heard of: Puppet, Chef, and CF Engine. And there's probably a whole bunch more. But probably the biggest one that you'll run across is Ansible. If you have any desire to work with servers and computers in the future, it's not a bad idea to invest a little bit of time in picking up Ansible and doing some work with it. So I'll give you a hypothetical scenario to think about. Remember, we think about what if scenarios. You've got your cluster all built, you ship it off to SC, bring it up online, and get everything prepped and ready to go for the competition, and then head off for the night for dinner and whatever you do as a social activity there. I don't know what the students do if you're allowed to drink or not. But you come back for the next day and then everything's ready to go. And then it's like, why is everything blank? And there's a file sitting there in your root directory saying, I've ransomed your machine. If you'd like your data back, you're welcome to pay us $12,000 or 0.25 Bitcoin. Now what do you do? And hopefully you have a good answer. Not saying it's going to happen, but planning for failure, this is probably a thing to plan for. Had you used a tool that does configuration management and then checked all of that, captured all the changes into that configuration management tool, and your way of managing the cluster is to apply entries into the configuration management tool. So think like policy or playbook. You put it all there, you run the tool, and it makes a change. You don't go and make the change yourself directly. And then if you had kept that configuration in Git and protected your Git, see how to use SSH key securely. This is one of the other places where you would use an SSH key and put a passphrase on it. You might be able to pull everything down and reconfigure the cluster before the competition starts. You don't have to pay the Bitcoin, and you don't have the embarrassing we got owned. Sorry about that. So think about it, consider it. If you'd like some ideas as to how to go about doing that, I'm happy to help. And whatever you do, make sure you test it. As was my colleagues paraphrasing one of my colleagues, a disaster recovery plan that hasn't been tested is not a disaster recovery plan. So work on it, think about how you're going to do it, throw everything away, drop it on the floor, and see if you can rebuild it. And if you can, you're in good shape. If you can't, figure out why and get to that state. All right, completely changing gears, something a little bit different. Back to the security part. Let's talk about network services. You have things that are listening on the network. The prime example is going to be SSH daemon. That's how you get into your machine and manage it. But you may have other things there that may or may not be necessary. I don't know what they are, and you don't know until you find out, until you go looking. But on the first order things, if you don't have a service running, it can't be attacked from the network. If you have a service that usually listens on the network and it's not running, then it can't be attacked from the network. And that's one last thing you have to worry about. But what's listening and how do you find out? In Linux, there's a couple of commands there that you can use to figure out what's running and listening on what ports. Now, if I got time, we can try using a couple of these to look at a machine. If you find stuff there, ask some questions. Does it need to be running? If the answer is no, turn it off. Systemctl, stop the service, disable it, and mask it. Knock the machine over and reboot it, bounce it, see if it comes back. If it's gone, great. If you find something is broken, well, I guess it needs to be running. Go and turn it back on. Otherwise, leave it off. If it needs to be running, yeah, great. Does it need to be public? If it doesn't need to be public and you have an internal network that's just specific to the cluster, by all means, reconfigure that service so it's only listening on that private interface. By the way, if you make that change, see the previous slide on configuration as code. That should be captured. And finally, unfortunately, if it does need to be accessible on the public interface, like your SSH might need to be, does it need to be accessible to everyone? If the answer is no, then we come to the F word. No, firewalls, not the other one. Although the other one may be invoked in this context, as sometimes it causes more pain than you might imagine. I'm going to catch flack for this because I'm telling a bunch of students that you may not always need a firewall, and my colleagues are like, you always have to have a firewall. If you're not doing it, you're not doing security. But I'm going to go out on a limb and say it's not always needed. And when might you come to that conclusion? Well, what kind of rules are you putting in there? If the rules are like allow all in, allow all out, what's the purpose? What's the point? The firewall needs to block stuff. If you're not blocking anything, then why have it on? Where it becomes really useful is where you have a requirement to allow some stuff in, but not everything. So you may say like some IP addresses are allowed in that are on the internet, then I don't want this whole thing open to the internet. So that's where you would put the firewall in. Should you turn on the firewall and start using it, there is these are all, Linux supports things called stateful firewalls, or state tracking, that allows the firewall and the kernel running on the machine to determine if a connection originated on a machine or is responding to an attempt to establish a connection. So in versus out. Make use of it. There's a filter in IP tables and a similar one in NetFilter. Talks about established. Make sure that you use it. Don't go and just set up blind rules and go, well, it's not working, so I have to allow all the ports coming in, the high number of ports coming in order to make this work. That established and state tracking is what makes you not have to deal with that. And then it may be tempting to turn on all of the blocking and try to disappear from the network. That's going to hurt. And it's not going to hurt you immediately. It's going to hurt you when you're trying to track down a problem and the firewall is interfering with your ability to track down the problem because the tools that you use to find the host and troubleshoot are not working. The common ones are turning off when blocking a connection using the drop target instead of reject. The drop target will just drop the packet on the floor, and it'll from the client side, it'll be as if the host doesn't even exist. Your attempt to connect will just sit there in timeout after a few minutes, and you'll go, I think my host is down, and then you'll try and ping it, and you've blocked ICMP ping, so you try to ping it, and then you'll see that you're not getting any ping responses back, and you go, yep, my host is definitely down, and then you'll sit there and power cycle it. But it didn't need to be power cycled because it was on the network all this time. It was just your firewall was blocking all of the stuff that you're trying to do to troubleshoot the problem. So don't be invisible. It's just gonna hurt. All right, so where am I? Wow, we're doing good on time. Let's chop on over to networking in a second. Does anyone have questions about the stuff that I've gone over in security?
I had a question about specifically SSH keys.
Okay.
So I know you said that you really only need one pair, but what are the advantages of like having more than one?
So the advantage to having more than one is mostly the ability to separate your exposure. And there's a little bit of privacy to it too. So as an example, consider that when you try to log into a server, an SSH server, all of the keys that are loaded in your agent are going to be attempted. Actually, it's a little bit less. It's a little bit different. It's a little bit more nuanced than that. When your SSH client connects to a server, the client is going to go, I have the following SSH keys available. It's a thing called a fingerprint or a digest, and it's a summary of that unique. It's a short string that uniquely identifies the key pair. It's based on the public key, so it's not like knowing the fingerprint is going to expose your key. But the remote server, if it's logging all of this information, is going to know that you've connected, and the following fingerprints are associated to you and the username that you tried to log into. In most cases, that's not a big deal. Like if you're connecting to one of our servers, yeah, we know who you are. If you're connecting to some random machine on the internet because you mistyped a host name or transposed numbers in an IP address, that might be a little bit more concerning because now that they have the fingerprints of your keys, there are places that those keys may be registered or documented. The one that kind of irked me was GitHub has an API, and that API allows a random person to query their API and say, hey, does anyone have this key? And they'll come back and say, well, yes, Scott Sakai has this key. Here's their email address. Here's their first name and last name. Here's their GitHub. Page. So I was not happy about that. And if you wanted to escape that sort of thing or try to bypass it, you would have a key for GitHub, and that key is only for GitHub, and you wouldn't load it into your agent unless you were interacting with GitHub. Whereas, and you would unload all of the other keys, or you would unload that key when you're not interacting with GitHub. So if you were to like SSH to a random server, the server wouldn't get that key that's associated with GitHub and know that it's actually you trying to connect in. The other time you want to have a different key is if you're using agent forwarding, and you may want to forward your agent so you can, say, for example, work on the cluster, but you don't want to also give the processes on the host that the agent's being forwarded to, like your login node. You won't give them access to your GitHub repos. If you had a separate key, like same thing, you would unload the key, and then if there was like an intruder on the login node, and they said, "Oh, this person's logged in, let me go and poke at GitHub real quick and see what they got," it's not going to work because they don't have access to the private key that's now sitting safely encrypted on your machine.
Okay, that makes sense.
GitHub, I can add to that too. By the way, the GitHub thing is kind of useful. Like when you're trying to, like if you're working on if you're like me, instead of setting up servers, sometimes you can just get people's stuff and put it on there. But I agree with Scott that like the one I have on GitHub is different from the ones I have on other things. So say this is another reason to have separate keys. If one is compromised, the other is not. So say that you accidentally send one over Slack for whatever reason, like you just messed up. Now they have access to that one. But say you use one only for your personal servers, and another one only for school machines, and another one for work. Those are independent of each other. So if one is compromised, the other is not. And the second reason, I guess this is even more careful. This would probably be something that Yuchin would do. He would put probably like an expiration on SSH keys. So it's like, oh, if I've used this key for over a year or 2 years, I think it's right about time that I change it. And then if you have separate keys, then you don't have to be changing all of them. But that's something that he would do. That one probably isn't that necessary. Oh, and another thing, the protocol, not the protocol, but the encryption method is different. For example, something that's very common used to be the RSA, but now people have determined it to be the RSA encryption method. Some people say that it's not as safe as before. So you could have different keys depending on what encryption method you want to use, just in case you think one is more safe than the other from things like quantum computing. So that's another reason.
I want to add a couple things there. With respect to post-quantum ciphers, none of the available SSH key encryption algorithms are PQ safe. So don't worry about that yet. There are a few. There's a couple of them that have been approved by NIST earlier in the year. So hopefully they'll trickle down and make their way into widespread use. But right now, yeah, don't worry about that part. My recommendation is that if you're rolling a new key, use ED25519. There's three that you're going to see: RSA, DSA, there's RSA, ECDSA, and ED25519. The Edwards curves are much smaller keys. You'll find logging in quite a bit faster, and they're not they don't have the same factoring problem that RSA keys do. So if you're really concerned about your security and you're stuck with RSA, you're going to be using like a 4096 bit key, which will take like half a second or a second to log in. And you're just sitting there like, is the network slow? No, we're just pushing bits around. And if you're using an Edwards key, it's just like it's almost like as soon as you hit enter, you're sitting at the prompt. ECDSA is an option, but the problem with all of DSA, with ECDSA and the regular DSA, is if your implementation is bad, specifically if you sign different data with the same nonce. If you ever sign different data with the same nonce, the private key can be derived. It makes no sense. It may make no sense to you, and that's fine. But just be aware that it's a little broken, even though it's widely used.
Could you repeat that? Did you say ECDSA?
Yeah, elliptic curve DSA. If the elliptic curve DSA algorithm involves the use of a nonce, random number, initial number, that goes into the signing operation. If the same nonce is used with two different things that need to be signed. It can be like data one, data two, and the same nonce is used. If an attacker sees both signatures, they can compute the private key. So there's a hack to the DSA algorithm where they generate the nonce based upon the digest of the data. So hopefully the only time you get the same nonce is if you use the same data. But if that implementation is ever misimplemented, as may happen if you're using crypto that was written by someone who's not a cryptographer, you may end up with a surprise later.
Yeah, I'll stick to my ED 25519 then.
Yeah. Um, Before I hop over to networking, I have a question for the general people here. Do you happen to have a thing called a YubiKey or a FIDO token? Uh,
Not sure what that is, so I don't think so.
Let me see if I can get a picture of one. Let's see here. Dismiss. Throw that over to there, and so something that looks like that. These guys, you can also have a YubiKey isn't the only one that makes these. They are in many different form factors. The idea, the whole thing is that they implement a standard called FIDO or U2F that is primarily used to allow web browsers to communicate with a hardware device that stores the crypto in the hardware, so it can't be copied out. It's actually really great for websites because phishing doesn't work with it. The URL is part of the thing that's used to compute the key. So when you go to a fake page, it looks like Google, but it's not Google. You may be confused and type in your OTP or approve the push. But if you're using a FIDO2 token, the because the URL is different, the key is computed differently, and you're not going to the attacker is not going to be able to log in and trick you into logging in using your token. I'm asking because there is also now support in SSH for FIDO2, these FIDO2 tokens, and you can actually generate a key on a token like this and forward it and load it up into an agent and use it just like any other SSH key, manage that it doesn't live on your computer where it can be copied off and misused by an attacker. You have to approve every use of it by tapping the little button, little gold button over here, over here, over there. You have to approve every use of it. So even if you have it forwarded off onto another machine that may be hostile, if an attacker is going to try and abuse your key, you first have to tap it before they can do anything with it. So if you don't have one, I suggest thinking about grabbing one. You can get the FIDO2 only that doesn't have all of the other YubiKey functionality. They're for under 20 bucks. And if you're like me and you just hate having to pull out your phone in order to use campus single sign-on, this thing works with that. You can register it. So when you log in, you just tap your key and you're in business.
Wait, so this can replace the Active Direct, like the Duo thing?
Oh yeah.
Oh, I'm buying one. Okay.
I'll see if I can demo that in I'll see if I can demo some of that later if we got time. By the way, how much time do we have?
Um. Oh wow, we're already. I think. Let's see. We started at 10, so 20 minutes. Also, Ferrari in the chat says, "Doesn't ITS give them out?" Do they?
If they do, that's news to me, but by all means, if they do, grab one. These things are nice. But let me touch briefly upon networking so that we can round this out. And if anyone wants to stick around afterwards, I can fumble my way through trying to use a demo the using a YubiKey or a FIDO2 token for both Campus Duo as well as doing SSH with it. So let me hop back to my other. Let me hop back to my other slides, and away we go. So if you have taken any introductory networking classes, you may have heard of a thing called the OSI model. And 7 layers, kind of like this. And I'm not gonna really go through them because most of the time we only deal with a few of them. Like layers 5, 6, and 7. It's like, whatever. We're not writing software. We're not writing file formats and protocols. So that doesn't matter too much. You're either using it or not. Layer 1, physical, that is like an hour presentation all on its own. We get bitten by things that happen in layer 1 all the time, and it's usually dealing with things like dust and exceeding the minimum bend radius of optical fiber. There's all kinds of things to be talked about with physical layer, and hopefully in your case you're using direct attached connector, direct attached copper, so you don't have to deal with those. That leaves layers 2 through 4. That's kind of where you spend most of your time if you're doing networking. And I was thinking about, how can we talk about layers 2 through 4 and in some meaningful way. And I thought this might be a good opportunity to learn through troubleshooting. So bear with me, I have not gone through a test drive with any of this, so it may be weird, it may be weird, it may be a little clunky, but let's try it out and see what happens. Let's talk about 2 machines here. I have one called Thinky. I have another one called FE, as in frontend.fuster, and I can ping these things. Ping, it pings. I can ping this one. I can ping it. But if I try to SSH, it gets stuck. You're like, hey, what the heck? That's weird, isn't it? And we can try saying, like, does a port open? So we can use like telnet to try and connect to the port, and we see that there's a connection succeeded and it's sent back a little bit of data. But what the heck, man? It's not working. So you may try to turn on verbosity and see if there's something weird going on. And we see that it's just getting stuck in the SSH handshake. So welcome to a layer 2 problem. This is one that you may encounter and figure out what's going on here. So we can use some troubleshooting tools. Ping is a useful one. And what ping will do is it'll fire off an ICMP packet to your destination. It says, hey, whatever's in here, send it back to me. And there's a little bit of state keeping in the packet, so the ping program can tell how long the packet took to show up or to go out to the other machine and come back, and what order it's coming in. And importantly, there's a size, a number of bytes of data. So we might be asking, let's see what happens if we try to send more data. Well, first we can say, let's send 1492. Send 1492 bytes. And surprise, it's not going through. It's supposed to, but it's not. So somewhere around there. In fact, there's another switch that you need to use most of the time. And this tells the kernel, yeah, I know I'm sending out a big packet, but try not to chop it up into little bits, please. And the maximum you would expect, 1500 byte MTU, you should at least be able to pass that number. Like I could ping another machine. Yeah. Oh, look at that. I can't do that. Can I do it on this side? Oh, that's interesting. We can do 1400. So it's obvious that the packet size is a problem, is a factor here. And in fact, you might want to check your MTU settings. So MTU is the maximum size of a packet that can traverse an Ethernet frame that can traverse the network. And that number is important because it advises the kernel if it needs to chop up packets or not. For regular Ethernet, it's 1500. And for high performance Ethernet that you might find in an HPC cluster, we usually run at 9000. And then somewhere in between, if you're using InfiniBand, I think it's like 4096 bytes. As you see here, the MTU is wrong. So it's like, well, duh. Let's fix that. If I remember the root password that I changed recently. I don't remember my root password. There we go. So let's go and fix this MTU. That should be 1500, not 1000. Somebody got carried away there. So I see now my MTU is down to 5000 or 1500. So I should be able to ping SDSC proper now. Oh, 1490. Sorry, 1472. There we go. Perfect 1500. So that goes through just fine. Let's check the same thing over here and see if that's been messed with. This machine has a lot of extra interfaces, but that's okay. We're only concerned with this one over here, number 590net. And I think that's probably fine where it is. So let's try SSH again. Oh, it made it further than last time. And I don't remember my password. It also helps if your keyboard doesn't stick. I'm going to cheat. So there, now I can log in again. That addresses that networking problem. So this was only a layer 2 problem. That means it was Ethernet going back to the OSI model. We're working down here with data link level with data link layer 2. Didn't have IPs or anything like that. This is just frames, and we're trying to send frames that were too big for the network through the network. The network goes, this is too big, I'm going to throw that away. And with predictable results. Connection works sometimes, doesn't work the other time. Let's hop over to a different host, host pair. So we have a login node. We got a login node somewhere. That doesn't work. So I can't ping it. It's down. Can I ping it from here? But I can ping it from here. So like, what the heck, people? It's important. This is now a layer 3 problem because we can see that there's connectivity from some places but not others. And as it so happens, they're on the same, what we call layer 3 subnet. They all live in this 192.3.1.2.1 space. The other host is 192.3.1.2.2. So at least as far as layer 3 goes, networking IPs, they're right next to each other. They should be able to see each other. Excuse me. But for whatever reason, I can't ping it from the outside. So how does this work? How does a packet work? Well, normally there's this thing called a default gateway, and there's in conjunction with the net mask, that's this number over here. The kernel can compute if an IP address is local, meaning I could just say, hey, who's got this IP address? Okay, I'm going to send this to you, versus not trying to make that request and just say, you know what, here, you deal with this, just get it to where it needs to go. And the way that's done is this IP address, it's actually a really long number. It's a 32-bit number. IPv6 is 128 bits, same concept. I take the net mask, which is the number of ones starting at the most significant bit, and do a bitwise AND operation across all of that, and you'll get a number. And they do the same thing with the destination IP, and if the two numbers are the same, then they're in the same network, hence the name netmask. And if that's the case, then the kernel will just go and scream down the Ethernet and say, hey, who has this IP address? Tell me who you are, and I'll send you this packet. If the two numbers don't match, then this default gateway comes into play, or the routing table will come into play. It may have more entries, but this one's pretty simple. It just is, if it's not local, throw it down to 192.31.21, and it'll deal with it. So what might be going on here in this case is the two hosts are right next to each other, so they're in the same subnet, and the default gateway is not in play. So let's go and take a look at the login node, and maybe we'll learn something there. Oh, look at that, connection refused. That's a different problem. So what we can tell from this one is when connections refused, that means there was the host was reached. The kernel got the packet to start to start a TCP session on port 22, which is the one that's used for SSH, and the kernel said go away. So we know the host is reachable, but for whatever reason, that's not working. That's a different problem. Let's figure out why we can't ping this thing from the outside. So for that, we need to get on the console, and don't have a console up. If this was in the machine room, you might be tempted to go and grab a crash cart, plug it in, but we have ways to cheat. We use IPMI. So let me flip my screen over for a second while I go and get my IPMI console up where you can take a look at it. So you can look at that instead right now. This might take a few minutes, so Baco, if you wanted to say anything, this is a good opportunity.
I think Mary had a couple things to say.
Oh, sure, go ahead, Mary.
Me? Hi, Scott. I want a
Hi.
YubiKey. I need to get a YubiKey. My stuff is about the hardware and the cluster, the status of our hardware. That's the main thing. But I'm Scott. I'm really liking your talk. Are
Well,
you
thank
going
you.
to do a webinar on using this material? It's really nice.
I don't know. It's not really to my level of polishedness that I would feel comfortable making a webinar about it.
Okay.
But certainly if there's a opportunity to do something informal, just like tear something down and like, here, let's break it and let's spend an afternoon breaking things and putting them back together.
That's fun to do, and with the students, it's really easy to do. We're good at breaking and putting things back together. Uh-oh, looks like I've helped you fill out the time, so
Oh,
I'll
yeah,
go
thank you.
back on. You're welcome.
So I'm on the wrong machine, aren't I? Because we just fixed Pinky. We just fixed Blinky. Yeah, this is the one that's further away. Okay. Let me let me go and find the right one. Apologies for that. Maybe I am on here already. I know I'm typing the password right. Active session. You lie. That one. I'm looking through my terminals to see if I have an open session somewhere. As it turns out, I do. Okay, back to you. Let's try it again. Ha. All right, so I'm cheating because this is actually a VM, not a physical machine, so I don't even need IPMI. I can just connect to the local console through my virtual VM manager, and let's take a look. So we said this might be an IP problem. So let's take a look at the routing table. And yeah, holy crap, look at that. There's no route in there. There's no default gateway. So let's add one. Let's see, that's an IP route. Do shoots. Of course not. So that's gonna be IP route and 0.0.0.0. Actually, give me a second on that. I forgot the syntax for this guy. So we've added a default gateway. Maybe this will just work. Hopefully, cross your fingers. So let's go and ping that machine. Ping. Still no love, huh? Now I can cheat a little bit. Um, take a look at my network configuration, and I can tell you that everything in here is correct. So we've got the default gateway, the address. So let's just bring it up and down. And hopefully that just took care of it. Because I know we don't want to look up how to use the IP route utility yet. There it goes, it's pinging. So maybe I can SSH in. And holy crap, yeah, it's broken. So there's this connection refused thing. So you might want to go and troubleshoot this a little bit, but what I can tell you is that we're now dealing with a layer above that because we're able to ping now. We're able to open a connection and have the kernel tell it to go away. So we're kind of like up here in either layer 4 or somewhere between layer 4 and layer 7. When you get a connection refused message like that, usually the first thing that you might want to check is the service running? So this connection refused happened, just click immediately. That's the kernel saying there's nothing here, go away. So let's go back onto the console and see if there's an SSH daemon running. Oh, hey, look at that. Someone turned it off. So now it is running, and I should be able to SSH in now, and everything will be cool, except I changed the host key. We'll worry about that part another time, but oops, SSH key gen.
So Scott, when you were getting the connection refused, that error doesn't happen when that port is just rejecting. I said that wrong, but
Yeah, the connection refused is the kernel saying please go away. And that happens if you're trying to connect to a port that isn't open.
oh, and the port wasn't open
passed.
because the program wasn't running. Okay, I get it now.
Correct. Yeah, there's nothing listening there. I have two problems. The first is I forgot I keep forgetting which password I set, and the second is that my keys on the keyboard bounce. So sometimes I get doubles. Okay, so yeah, I'm in now, and everything's kind of nice and peachy keen. We were talking earlier about doing auditing or inventorying your listing services. There is a command for that. I don't know if I have sudo on here. I don't have sudo, so I have to ask you. Okay. That's the first one. If it was there. Do I have LSOF? Okay.
For the netstack command, I usually use lntu. That's just the one I've grown accustomed to. I think the one you use also shows Unix sockets or something like that, right? But is that accessible from the outside? I thought only the first part is.
Unix sockets, or the Unix sockets, also known as Unix domain sockets or UDS, are only accessible on the machine. They're they look like files. They look like files. They have a location in the file path, but they're not files. They are something in between. But yeah, you can't connect to a Unix domain socket directly from the outside. You can have a program that does it. Like you can configure SSH client to forward a connection from the outside to a Unix domain socket. But just by itself, it's not reachable from the outside. There's netstat. Hmm. What does provide netstat?
I was doing like net utils or something.
Hey, net details?
I don't remember. I just had to do it like a week ago. Yeah, net dash tools, I guess.
Okay, let's go ahead and cram that in there. App 10 still.
Also, I know we're approaching an hour, and Mary has been holding on to message about hardware, which I hope is good news.
Ah, okay. So I will leave you with that then. Here is the net output of netstat-a and p. We got a little bigger for you. You can see that there are some processes that are running. Here is SSHD. It is listening on all IPs, not just a particular interface. And yeah, if you had more interfaces on here, you could say, for example, configure SSHD to only listen on the internal interface for your internal nodes, so you can only poke at them from the internal network, and the way in is through the front end. Something like that. You may have things like NFS or some random web server to make it easier to administer the machine. You would find those here and go, I don't want you on. Go away. You can turn those off. Um, yeah. I guess I'll let Mary go and talk about that. And while she's doing that, I'll see if I can briefly get set up to show you what a YubiKey login process looks like.
Yeah, that's great, Scott. Thank you for covering security in such great detail. You could stop screen sharing if you want to, or keep screen sharing. And, I'm sorry, I don't have any great news, Paco, or in everybody. And we're reaching out to everyone we can think of, including the RDS people on campus. And nothing yet, although I have a package that arrived today, and I think it's the Instinct GPUs, two of them. So it's getting kind of tight here, and I'm just trying to figure out what we can get going. And Paco, I know you've met with a few people. Do you have any follow up messages from these people, or uh, anything that you haven't shared with everybody from your side of things? I have that Brian Balderson in the RDS group is looking around with their contacts, but I have to give them a couple of days. So Monday I want to do like a really serious outreach and coordination, all hands on deck kind of email, which every time I get ready to send that out, people like Brent and Gorda go, wait, 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 we've got things in the works and nothing's happening. So, how about you, Paco? Anything on your side?
So I know that people from Micus are getting us nicks, and it looks like that's going well. Though I don't really feel comfortable with actually I shouldn't be recording this screen.